Okay, so before you try today's Google form, let's just go over everything that we've kind of talked about so far with factoring. I'm going to do a little review. I'll do 5 problems, and hopefully, this will help. So, yesterday, um, everything that you did with the trinomial, either you were able to pull out a GCF first, or this first number here was a 1. So for example, they usually just started with x squared or n squared because the imaginary 1 is just always there. Well, now what happens when there's a coefficient there? So again, the first thing you want to see is there a GCF that you could take out, right? Because if there is, that should always, always, always be your first step. So if I look at the numbers, I have a 5, a 10, and a 20. So do they have a GCF in common? Well, the first thing you should always check for is to see if the smaller number goes into the bigger numbers, right? So does 5 go into 10? Of course. Does 5 go into 20? Yes. So I can take out a 5. Now, if I look at the variables, there's n squared, there's n here, but there's no n's with the third piece, with the third term. So I can't take out any n's. All right, so let's see what would be left inside. 5 times what would give me 5n squared? Well, 1 n squared, right? Or just n squared. 5 times what would give me 10n? 5 times 2n. And then 5 times what would give me 20? 5 times 4. Okay. So GCF should always be your first step. Then you look inside at the remaining trinomial and see if you can still keep breaking that down, right? So you should now be asking yourself, well, does anything multiply to 4 and add to 2? So if I make my little table, I want to multiply to 4, but add to 2, right? So what are all my factors of 4? Well, there's not that many. It's either 1 times 4 or 2 times 2, right? So if I add those together, 1 plus 4 is 5, and 2 plus 2 is 4. So nothing actually adds to give you a 2. So this is as far as you can go. So this would be your final answer. You took out the GCF 5, and then this is what's remaining inside. Okay. Well, now what happens if you look for a GCF, but there is none, right? 3, 2, and 5, the only thing they have in common is a 1. You also can't take out any variables because this doesn't have a p with it. So there's no GCF here that you could take out. All right, so we're going to use something called the AC method now. Whenever you have a trinomial, right, tri means 3, so there's 3 pieces. So you always have an a B, and a C. Okay, so A is 3, and C, the minus belongs with the 5, so that makes that a negative 5. So it's called the AC method because you want to multiply A times C. So I'm going to multiply 3 times negative 5 to get negative 15. So our job now is to find something that multiplies to negative 15 but adds still to this middle term, which is a negative 2. So I want to add to negative 2. So I need to list out all the factors of negative 15. So I have 1 times negative 15, or negative 1 times positive 15, 3 times negative 5, or negative 3 times positive 5, right? So now again, at this point, I would use my calculator because these negatives can be tricky. 1 plus negative 15 is negative 14. Negative 1 plus 15 is positive 14. 3 plus negative 5 is negative 2, and negative 3 plus 5 is 2. So remember, we were looking for a negative 2, So these would be my numbers that I would need to use here. Okay, so that's what you're going to use now for your box method. So let's go back to setting up our box. So my first term was 3p squared. My last term was -5. And the two numbers that I found that worked are +3, so 3p, and -5p. Okay, so now I need to get the GCF of each row and each column. So for this column, the only thing a 3 and a 5 have in common are a 1, but I could also take out a p. This column, same thing, 3 and -5, the only thing they have in common is a 1. This first row here, I have a 3 and a 3, so they have a 3 in common. And I can also take out a p because p squared, or p to the first, the smallest variable is a p. And then down here, -5 and -5, I'm going to take out a -5. Remember, you only take a negative out if they're both negative or if the first term is negative. I can't take out a p because this second box doesn't have a p. So my final answer here should be 3p minus 5, right? Because that's what I got on the outside over here. And then my other piece is p plus 1, or 1p plus 1. Okay, so I know this seems like a lot of steps, but if you understood the box method and finding the GCF, you really just have this extra step now in the beginning, which is to multiply a times c. Okay, when you put these two, the first and the last term here, that's what you're multiplying. 3 times -5 gave us -15. All right, so let's try another one like that. So, is there a GCF? 2, 3, and -9. 2 doesn't go into 3 or 9, so the only thing they have in common is a 1. All right, so I need to do the AC method. So this is my first term. This is my last term. So those are my two pieces that I need to multiply because that's A and C, right? So what's 2 times -9? -18. So I need to find all the factors of -18 that add to +3. All right, so factors of -18. 1 and -18, -1 and 18, 2 times -9, -2 times +9, 3 times -6, and -3 times +6. Okay, well, again, if you go across and you use your calculator and you add them together, you get -17, +17, -7, +7, -3, and finally +3. So again, because my middle term was a +3, this is what I was looking for. These two numbers right here. I need a -3 and a +6. Don't forget to give them both n's. And now I'm ready to find the GCF for each row and each column. So let's do this one first. 2 and 6. What's the GCF there? 2. And I can also take out an n. Over here, -3 and -9, the GCF is a -3, right? Because they're both negative. Okay. Going for my first row, 2 and -3, the only thing they have in common is a 1, but I can also take out an n. All right, so I could take out a 1n. And then down here, 6 and negative 9, the GCF there would be a 3. So if I put this all together now, my final answer should be 2n minus 3. That's what I got on the top. And then along the side, I got a 1n and a positive 3. So n plus 3. Okay. All right, and then again, just another quick little review. You also have those perfect square trinomials, right? So 16, 40, and 25. If you tried to look for a GCF, there isn't any besides one. And you could do the AC method here, but 16 times 25, that's going to give you a really big number. So instead, if you notice the perfect squares before you even start, then you don't have to do the AC method. Okay, so for a perfect square trinomial, your first term and your last term have to be perfect squares. Okay, so if you recognize that, then all you have to do is take the square root. So what's the square root of 16? 4. And the square root of b squared is b. What's the square root of 25? 5. And because this middle piece is a negative 40, it's going to have to be a minus. Now, you can write it twice, or you can use the shortcut, which is 4b minus 5 to the second power. So that's acceptable. Or, because you're multiplying something by itself, we can just write it once, 4b minus 5 to the second power. Now, just to make sure that it is in fact a perfect square trinomial, you should kind of check it or FOIL it to make sure it really works. Because remember, it would have to be the outside pieces and the inside pieces added together to give you that middle term. So 4b times negative 5 is negative 20, and negative 5 times 4b is also negative 20. So negative 20 and negative 20 gives us this negative 40 in the middle. Okay, so really what you're doing is you're just multiplying the two pieces together and doubling it. So 4 times negative 5 is negative 20, and if you double it, that's how you get the negative 40. Okay. We also have perfect square binomials, right, with two pieces. So now with this one, you're still going to take the square root, but since there's only two terms and the second term is a negative, right, the only way to get a negative 25 is to have a positive times a negative, right? You need one of each. So it doesn't matter which one goes first, but you need one of each. And then you're still going to just take the square root. So what's the square root of this first term? Well, the square root of 4 is 2. And the square root of m squared is m. What's the square root of the second term? The square root of 25 is 5. Okay. And then you're just going to copy it again, but remember, this one is a negative. So it's 2m minus 5. Okay, and again, the way to check that would be if you FOIL this out. Remember, 2m times negative 5 is negative 10m. And then 5 times 2m is positive 10m. Well, if you were to add them together, what's negative 10 and positive 10? You get 0. So they cancel each other out, and that's why there is no middle term here. There's no term in the middle with an M because they got canceled out. Okay, so hopefully that kind of just reviews all the different types of factoring we've talked about so far. Remember, you have all the videos that we've posted so far along with the answer keys. Um, so you hopefully have all these notes written in your notebook to use for when you try these Google form questions. All right, let me know if you guys have any questions.